Scientific notation is a way to write numbers that are very small or very large without having to write tons of zeros, and it's in the form of m times 10 to the nth, where m is a number that's between 1 and 10, so it can be equal to 1, but it can't be equal to 10, and n tells the number of positions to move the decimal point. Okay, 3.2 times 10 to the fourth is a number written in scientific notation. So if you see an exponent of 4, that's a positive number. That tells you that's a number greater than 1. So I'm going to basically move my decimal point 4 places. 1, 2, 3, 4. So it's going to end up here when I write this number in what's called standard or Florentine notation. So every place I have one of these little humps, I'm going to put a 0. So that means that's 32,000. Okay. If my exponent is negative, okay, so it's a negative number, it's going to be something less than 1, or a decimal. So I'm going to move the opposite direction. So I'm going to move 1, 2, 3, 4 positions. And again, every place I have one of those little humps, I'm going to put zeros in to get my number there. If I'm trying to write a number in scientific notation, I have to look at where the decimal point is. So again, there's not really one here, but it would be written at the end of this number. And then I need to move my decimal so that I get a number between 1 and 10. So in the 4,200,000 example, I have to get my decimal point to be 4.2. So I'm going to move it 1, 2, 3, 4, 5, 6 places. So this will be 4.2 times 10 to the 6th. Okay, if I have a decimal, I'm going to move the opposite direction, and I'm going to get my decimal to go here between the 2 and the 7, because 2.751 is going to give me a number that's between 1 and 10. So to move my decimal point, 1, 2, 3, 4, 5, I'm moving it 5 places, but since it's a decimal, my exponent's going to be a negative number. All of your sig figs are going to be in the m part of your number. So all of these digits, since they are sig figs, have to go into this m part. So I'm going to move my decimal point from here to here. So the 9.8700, and I don't need the bar anymore because we never use a bar with a decimal. And then I'm going to count my place values: 1, 2, 3, 4, 5, 6, 7, 8. So this would be 10 to the 8th. So be careful when you're counting. Some people stop where this digit is. You got to actually stop where the decimal point's going to go, which is here. So that's why you have to go to all of these place values. And again, if it's a negative or a decimal, we're going to have a negative exponent. Again, this 0 here at the end is a sig fig, so all of these numbers have to be in my m value, so 3.070. And again, I only have to count how many places it takes me to get the decimal between the 3 and that first 0. So 1, 2, 3 times 10 to the negative third. So you should have a worksheet that has examples for you to practice on this. Please complete that at the conclusion. This is the conclusion of this presentation.